when you take the test that you need to do, and you'll get lots of practice on your homework today for it, is identify if the substance is ionic or if the substance is covalent, because there are two sets of rules, two different foreign languages, and you don't want to be speaking one when you're supposed to be speaking the other. Or worst case scenario, you blend the two languages and make up your own thing that's not right. Okay, so first thing is you look at the periodic table, and here's actually a shortcut. Because the first element is always the metal, if it's ionic, you only have to check the first one. So find aluminum on the periodic table. Since it is to the left of the diagonal staircase, that tells me this is a metal, which means it's ionic. Ionic means you name the two halves, first and last name, so Al is aluminum, Br is bromine, but for ionic you change it to bromide. You then check to see, does it need a Roman numeral? When do we need Roman numerals and when do we not? Yeah?
If we don't know how many valence electrons it has, then if we don't know it, then we need Roman numerals and we have to figure it out. But if they're in like the categories where we already know what the valence electrons are, then we don't need it.
Perfect. So how she said it for those that couldn't hear is it's based off if you know its charge or its valence electrons. If we know how many valence electrons it has, like aluminum we know has 3, then it doesn't need a Roman numeral. So that's why that is correct. Okay? Okay, very good. Number 2, give me a thumbs up or thumbs down. How's that one look? Thumbs up, thumbs down. Do you think it's wrong? Do you think it's right? This one is actually okay. So let's talk through why it's okay. Does anyone have a preference? Do you want to go name to formula or formula to name? Let's go the other way this time. So if I'm given the name, nickel 2 carbonate, okay? So going in reverse for ionic, you write the symbol. So the symbol for nickel is Ni. Carbonate, this is significant. What does that 8 tell me?
That is the formula changes the ion.
Good. Everyone's looking through their green packet. It's a polyatomic, which is CO3 with a 2- charge. What is this telling me?
That there's 2 charges.
Good. Now the thing with ionics and formulas is the balancing. Okay? If this has a +2 and this has a -2, how many of each do you need to make it be balanced? 1. Just 1. So that's why the final formula is just NiCO3. So that's why it is correct. So that's why if some of you were thinking that you needed to have a 2 here because of that 2 there, it cancels out in this case. It is important to think about it, but it's not always in the formula. Okay, questions on that one? Okay, number 3, thumbs up or thumbs down, what do we think? Wrong or right, how it's written? If you're giving me a thumbs down, have a smiley face because you are correct. It is wrong, that sounds weird. Can someone who identified it's wrong help us understand why? This is how it's written. Anyone want to help us out what's wrong with or how we know what we need to fix? Yeah.
Is it because you don't need 2 and 3 of those, they cancel each other out fine?
Very good. So if this is the name, okay, going back to what we just did, that means it's Fe2+. Oxide is oxygen, which has a 2- charge, and they cancel out. So the correct formula for this name would be FeO. The correct name for this formula would have actually been iron 3 oxide. So you could have corrected it either way. So this matches this matches that, but those don't go together, right? that one. Okay, number 4, give me thumbs up or thumbs down. How's this one looking? Very good. You give me a thumbs down, have a smiley face, because you are right that it's wrong. This one hopefully was pretty easy to identify. How do I fix this one?
You just switch them.
Yeah, it's just, you write them in the order it's given, right? So it should be sodium sulfate, not sulfate sodium. So you don't flip-flop the order. Very good. Have a bonus smiley face for helping us out there. Okay, number 5. Give me a thumbs up or thumbs down. How does number 5 look? So number 5 is correct as written. Once again, if you go to the name and balance out the charges, that's where the 3 and the 2 come from. Is by fixing those. So, okay, number 6, thumbs up or thumbs down. How's that one look? Oh, good work. That one is wrong. Have a smiley face if you identified that. Can someone help us out? How do we fix number 6?
It's supposed to be nitrate because it's the polyatomic ion.
Very good. Have a smiley face for that. Right, so since this is NO3, it shouldn't be nitride, right? It should have been nitrate. Or this should have just been Ca and N to match calcium nitrate. Right, so you could have fixed it once you get either way. So this should be with 8. This would have been Ca3N2. So with ionics, IDE is reserved for elements. ATE and ITE are reserved for polyatomics. Now keep in mind, I picked these mistakes as things I saw students do on the test last year. So learn from their mistakes so you don't make the same ones, okay? Okay, which one are we on now? 7, thank you. Okay, thumbs up, thumbs down. How's 7 looking? And as we go through, you want to change your original thought because you learned more, you can change. If you said something that's thumbs down and you think it's right or vice versa, you can change. But number 7 is correct as written, very good.
I'd be like double checking myself.
Oh.
I was like, I don't really know.
Number 8, thumbs up, thumbs down. Number 8 is wrong. Have a smiley face if you identified that. Can someone tell us how to fix number 8? How do I fix that
The
one?
element is just written wrong. We need to put that I.
Good. So it's not aluminum fluorine. It should be aluminum fluoride. IDE. Good. Have a smiley face for that, Rachel. Okay, number 9, potassium acetate. Thumbs up, thumbs down. How's that one looking? That one does look good. Have a smiley face for that. Oh, I guess that's a bonus. It was like a thumbs up, but that's okay. Which means by default number 10 is wrong, because if you've been keeping track, we've only done 4. But if you identified 10 is wrong, have another smiley face. Can someone tell me how to fix number 10, or what's it missing?
I mean, I can answer it, but if someone else wants to.
Okay, Rachel's offering the smiley face, someone else knows how to fix it. Alright, take it away. How do I fix it?
So we don't know cobalt's like charge, and so we have to figure that out. So if it says we need 2 nitrate and 3 cobalt, then you ended up needed 2.
Very good. So the
electrons.
problem here, you can only actually fix the name, is this name has to have a Roman numeral. So otherwise it doesn't work. Because you gotta think about going back and forth. And if I gave you the name calcium nitride, it would be impossible for you to come up with this formula. If you don't know how to balance it. So, any general questions there? Yeah,
How'd you get the Roman numeral for the last one? I kind of.
for this one. So the way you find, so this was given, right, is you go reversing of the balancing. So the way I think about it is go to the periodic table, find nitrogen's charge.
So it's -3.
Good. You have 2 of them, so in a sense, this side is adding up to -6, which means this side needs to add up to +6.
Okay.
You have 3 of them,
So you needed two.
So that's why it's a 2.
Gotcha.
Yeah, very good. Yeah, good reminder though. That's sometimes I think the hardest thing is the reverse balancing, so. Any other general questions? Okay, let's just recap really quick, and if you wanna write any of this down on, so you pull your assignment packet. The very, very last page in your assignment packet is that review sheet with the little triangle. I'm just gonna do a little review of ionics and covalence. If you wanna write any of this down on there, you're also welcome to do it however you want. But, just kind of a quick overview of what we have here. Okay, so for ionics, okay, so let's talk about name, and formula, and then we'll talk about formula change. And then we'll talk about covalence, named formula, and vice versa. Am I in the screen still, Benson? Yeah. Okay, once again, the biggest mistake I see made is mixing up our languages. So this is one language, this is another language. There are similarities between them, right? Just like in foreign languages, right? There's similarities between Spanish and French. But they're not exactly the same, so you've got to treat them differently, okay? Okay, everyone pause for 1 second. Everyone stand up. See some droopy eyes, I gotta wake you up here. Stay with me. Stand up, stretch, and turn to someone nearby and tell them your favorite breakfast cereal. Go.
What's your favorite breakfast cereal? Cinnamon Toast Crunch.
Oh, that's
That is the best answer. Or the
We just had the same favorite breakfast
Oh, yeah,
cereal.
those are good too.
Those are good.
Cause I just heard you.
Okay, you can sit down now. Students at home, go ask your brother what their favorite cereal is. Or sister, or dog.
Your dog?
Oh my god.
Dog, what is your favorite cereal, man?
Okay, here we go. So, ionic, if I'm given a name, and once again, just to remind you, so this is when you have a metal with a non-metal. Okay? If you're given a name and you need to write the formula, the big thing with ionics is you need to identify if there's a polyatomic. From a name, what will indicate there's a polyatomic in there?
What it ends with, so
Good.
like, is it 8?
Uh-huh.
And there's another one,
Ite.
8, 9.
If you see 8 or ite, that means look at the periodic polyatomic chart. If it ends in IDE, then you're looking at the periodic table. Now there are two polyatomics that end in IDE. Cyanide and hydroxide. But hopefully you'll know that by reading those, that's not an element you're familiar with. So, if in doubt, you can always check it too, right? If you're like, I'm not sure.
Is it if it's like more than 2 normally, like as a pair, it's like probably a
Yes,
combination?
which would help you here, but in this case, in the name, right, you have to identify from the name. But you are right in the reverse direction, Rachel, that, yeah, there's gonna be more than one capital letter. So, okay, so you need to identify polyatomics, you need to find all charges, and then balance the charges. Okay, going in reverse, if I have a formula and I'm writing the name, okay, same thing is you do need to identify if there's a polyatomic. which in this case, you're looking for more than one or more than two capital letters, I guess. Right, so if you see lots of capital letters, there's a polyatomic in there. You need to change the ending of elements. I guess I should say the second element, the first one doesn't change. We change the second element to IDE at the end. And then finally, you need to do Roman numeral if necessary. Don't forget about that Roman numeral. Once again, this is not like a full, this is kind of an overview, so if you need more details, we can go into that as we start working, okay? Any general questions on ionics? Okay, some reminders about covalence, okay? So if I'm given the name of a covalent and I want to change it to a formula, okay, then you're just going to change the not subscripts, that's what we're changing them into. Change the prefix into subscripts. Okay, so for example, if it gave me the name, let's say dihydrogen monoxide, okay, so the prefixes are these funny things in front, so di and mono. Di means how many? Two, so it'd be H2, because hydrogen, 2. Mono is the prefix for 1, so oxide is oxygen, so that's the fancy name for water. Dihydrogen monoxide. There's actually a really funny YouTube video of a guy a few years ago who went around New York with a petition to get rid of dihydrogen monoxide. And he convinced like tons of people to sign it. When pretty much they're signing to get rid of water. Yeah, but it's funny because he actually gave like a bunch of true facts about it. Like, it kills this many people every year because, you know, people drowned and like, and they're like, it's in our, you say, it's all over our pipe systems. Well, yeah, because there's water in our pipes. But that's why, yeah, you gotta, don't believe everything you see, right? Or it makes you know what you're talking about. So, okay, questions on that? Okay, and then it's just the reverse going the other way. So if you're given a formula, then you're going to change the subscripts. To prefixes. Once again, I highly recommend writing those prefixes just on your note card. Some of them are logical, like it just makes sense, but. And then the other thing is to change endings. To IDE. So, for example, let's say I had P3Cl6. Find your prefixes. So the prefix for 3 is tri. So it's going to be triphosphorus. Number becomes the prefix. Prefix for 6 was hexa. And then you gotta change the ending to "ide", so it's gonna be hexachloride. Now once again, on the test, none of the questions with naming, you're going to have to type. Because spelling is a little crazy in chemistry, and I don't want you to get docked just because you spell something wrong. So all the ones are gonna be like they're matching, or you're gonna like drag and drop, things like that. So don't stress if you're like, I can't spell these things. As long as you know how to get the right beginning and the right ending to recognize it, you'll be fine.
Well, we have like questions like what we did with the warm-up where we have to find like what's wrong, and if we do, does it matter which one we correct?
It's, if there are any of those, it'll be like multiple choice, so like narrow down which one.
Okay,
So,
cause, like, yeah.
yes, because you're right, because you can fix it either direction, so, good question. Any other questions for now? And that's pretty much the test. The test is just, I mean, if we look through our ICANs, it's just names and formulas, and then finding charges is the first ICAN. So that's the other thing you'll wanna make sure you're good at, so. Okay, go to, let's go ahead and then just we'll get to work, and then I can come help people with their individual needs. But if you feel good, you can get going. So the last review is this assignment in your packet called Mixed Nomenclature. This is kind of the review for the test because it does both kinds blended together. Now, if you haven't done the assignment right before that, I would maybe do that first. That's the one that corresponds to the last time's lesson, and it's really, really fast, the covalent nomenclature one. So if you haven't done that, maybe do that first, then transition into the mixed nomenclature, okay? Once again, the answers to these are posted, so you can make sure you're doing it right before you start the test. Feel free to talk to each other about it, ask me about it, but we'll just work on this for the last 20 minutes of class. Okay, ready and begin.